I'm Yixuan Lin, and I will work on coding out our innovation.
Hello, my name is Changyu Chen, and I'm working on background and market research.
I am Mu He, and I'm working on writing and editing.
Hi, I'm Yikai Zhao and work on the financial modeling part of the product. I hope that DeepWise can bring about huge improvements to state-of-the-art algorithm. This is an overview of our method. Input image for the adversarial image detector gets fed into the neural network. This is on the bottom row. The mean and covariance of the result of the input image after certain operations is calculated. The neural network also predicts the class of the input image. Let's call the class C. The distribution of class C images in the training set is compared to the distribution of the input images values. The Mahalanobis distance, that is, the difference between the two distributions, is calculated. This is repeated for other parts of the neural network, and these Mahalanobis distances are fed into a linear regressor, which judges whether the input image is adversarial or not.
The previous state-of-the-art method, which needs to compare the distribution of values of the input in each layer with the distribution of training values for each class one by one. So the adversarial detection speed is slow. So if there are 100 classes, then there has to be 100 comparisons. However, DeepWise only needs to compare the distribution of values in each layer with the distribution of the category predicted by the neural network. So the adversarial detection speed is fast. So even if there are 100 classes, there will only be one comparison. For example, since the input image is judged by the neural network to be a car, the distributions will only be compared to the training distributions of the car category.
AROC is a measurement of accuracy, and the higher the better. As shown in the table, DeepWise has an AROC comparable to the baseline, and significantly better than some other methods. This holds true in different networks, attack methods, and image datasets. Such a satisfying AROC allows DeepWise to effectively spot out adversarial images.
So the last part is about its speed. For all tested network and datasets, DeepWise is faster than the baseline in terms of theoretical computational complexity, with up to 87% complexity reduction. For example, if an image is to use ResNet 34 and CI400, the detection of adversarial input would take around 10 seconds on a normal computer, which can be slow and frustrating. This is also visualized in the graph on the left. This allows DeepWise to run smoothly while filtering out inappropriate images accurately.